Surviving hurricanes and typhoons is like preparing for a major exam. You need to study the warnings, gather your materials, and have a plan in place. Just as a student prepares by gathering notes and staying updated with class announcements, you should secure your home by boarding up windows and bringing in outdoor items, and stay tuned to reliable news sources for updates. Picture the storm as a giant, unruly guest. You should stay indoors, away from windows, and in a secure part of your home, like an interior room or basement, much like hiding in the safest part of a house during a wild party. If authorities advise evacuation, it's akin to taking a detour to avoid traffic. Follow the recommended routes and head to the designated shelters to ensure your safety. Think of your emergency kit as a survival backpack for a wilderness trip, filled with essentials like water, food, medications, flashlight, and important documents. And just like checking the weather before a hike, always have a battery-powered radio to stay updated on the storm's progress and follow official advice. Imagine a swirling vortex of immense power, capable of unleashing nature's fury upon the world. We call them hurricanes, typhoons, or cyclones. These are not different beasts, but rather different names for the same awe-inspiring phenomenon, the tropical cyclone. Just as a rose by any other name would smell as sweet, a hurricane by any other name is just as powerful. These swirling tempests are nature's way of reminding us of the immense forces at play on our planet. Think of it like this. You order pancakes for breakfast in America, but your friend in France might order crepes. Both are delicious, flat, and cooked on a griddle. They are essentially the same thing, just with different names depending on where you are. Hurricanes are tropical cyclones that form over the Atlantic Ocean or Eastern Pacific Ocean. Typhoons, on the other hand, are tropical cyclones that brew over the northwestern Pacific Ocean, and those swirling storms in the South Pacific or Indian Ocean? We call those cyclones. No matter the name, these storms share a common origin and a formidable potential for destruction. Understanding these storms is the first step towards respecting their power and preparing for their wrath. The structure of a hurricane is a marvel of nature's fury, a complex system of interconnected parts working in unison to create a symphony of destruction. Imagine a spinning top, its outer edges a blur of motion while its center remains eerily still. This is akin to the structure of a hurricane with its distinct eye wall, and rain bands. At the heart of the storm lies the eye, a zone of surreal tranquility amidst the surrounding chaos. The eye, typically 20 to 40 miles in diameter, is characterized by calm winds, clear skies, and strangely warm temperatures. It's a deceptive calm, a brief respite before the storm resumes its onslaught. Surrounding the eye is the eye wall, a towering ring of thunderstorms where the storm's most violent winds and heaviest rainfall reside. Here, winds howl at unimaginable speeds, often exceeding 150 miles per hour, and torrential rains lash down, flooding streets and overwhelming drainage systems. Emanating from the eye wall are the rain bands, spiraling bands of thunderstorms that extend outwards from the center of the storm. These rain bands, hundreds of miles long, can bring heavy rains, strong winds, and even tornadoes, extending the hurricane's reach far beyond its compact center. Understanding the structure of a hurricane is key to comprehending the different hazards it poses and preparing for its multi-pronged attack.
Section 4. Categorizing the chaos. The Saffir-Simpson scale explained. In the face of nature's fury, it's only natural to wonder, how bad will it be? How much damage can we expect? To gauge the potential impact of a hurricane, meteorologists turn to the Saffir-Simpson Hurricane Wind Scale, a vital tool in weather forecasting. This scale, ranging from Category 1 to Category 5, classifies hurricanes based on their wind speed and the potential damage they can inflict, providing a clear picture of the storm's power. Think of it like levels in a video game, each level representing a higher degree of difficulty and a greater challenge, demanding more skill and caution. Category 1 hurricanes with wind speeds of 74 to 95 miles per hour are like the first level manageable but demanding caution and preparedness. They can uproot trees, damage roofs, and cause power outages, disrupting daily life. As we move up the scale, the intensity and potential for damage escalates significantly. Category 3 hurricanes, with wind speeds of 111 to 129 miles per hour, are a significant threat, posing serious risks to life and property. They can tear off roofs, snap trees, and cause major flooding, leading to extensive damage and danger. Category 5 hurricanes, the most powerful storms on the scale, are the final boss, packing winds exceeding 157 miles per hour, capable of unprecedented destruction. These catastrophic storms can level homes, inundate entire coastlines, and leave behind a trail of unimaginable destruction, altering landscapes forever. The Saffir-Simpson scale, while primarily focused on wind speed, provides a crucial snapshot of a hurricane's potential impact, helping to predict the severity of the storm. It allows authorities to issue appropriate warnings, prepare evacuation routes, and deploy emergency resources effectively, ensuring public safety. Understanding the scale empowers individuals to make informed decisions about their safety and take necessary precautions, potentially saving lives and reducing harm.
Section 5. When nature's fury knows no bounds, global hotspots. Hurricanes and typhoons are not random occurrences. They are most likely to form in specific regions around the globe where conditions are ripe for their development. These regions, known as hurricane basins, are like breeding grounds for these powerful storms. One of the most active hurricane basins is the North Atlantic Basin, encompassing the Atlantic Ocean, the Caribbean Sea, and the Gulf of Mexico. This basin is particularly active from June 1st to November 30th, a period ominously referred to as hurricane season. Coastal communities along the southeastern United States and the Caribbean islands are frequently in the crosshairs of these Atlantic hurricanes. Across the globe, the western Pacific Ocean, particularly the region near Southeast Asia, experiences the highest frequency of tropical cyclones, known here as typhoons. The Northwest Pacific Basin is active year-round, with peak activity typically occurring from July to October. Countries like the Philippines, Japan, and Vietnam often bear the brunt of these powerful storms. Another active region is the Indian Ocean, where cyclones, as they are known in this region, pose a significant threat to coastal communities in countries like India, Bangladesh, and Madagascar. These cyclones typically occur between April and December, with peak activity in May and November. Understanding the geographical distribution of hurricanes and typhoons is crucial for effective disaster preparedness and risk reduction efforts. By knowing where these storms are likely to form, communities can better prepare and respond to these natural disasters.
Section 6. Predicting the unpredictable, forecasting hurricanes and typhoons. In the realm of weather, predicting the path and intensity of a hurricane or typhoon is akin to forecasting the whims of a tempestuous child. Challenging but not impossible, and always requiring vigilance. Thankfully, advancements in technology have provided us with powerful tools to track these storms and anticipate their next move with greater precision. Satellites, orbiting high above the Earth's atmosphere, provide a bird's-eye view of hurricane development and movement, capturing every twist and turn. Like watchful guardians, they monitor the location, size, and intensity of these storms, relaying vital information to meteorologists on the ground in real time. Radar systems, strategically positioned along coastlines, act as our first line of defense, detecting approaching storms and measuring their wind speeds with remarkable accuracy. But the real game changer in hurricane forecasting has been the advent of sophisticated computer models, which have revolutionized our approach. These models, fed with massive amounts of data from satellites, radar, and weather balloons, simulate atmospheric conditions and predict the future track and intensity of hurricanes with increasing accuracy and reliability. Think of it like using a GPS to navigate a complex city, where every turn and obstacle is mapped out. These models provide us with the best possible route, but unexpected detours can still occur, reminding us of nature's unpredictability. While forecasting hurricanes and typhoons remains an imperfect science, these technological advancements have significantly improved our ability to anticipate their arrival and prepare for their impact more effectively. Accurate forecasts allow for timely evacuations, deployment of emergency resources, and ultimately, the saving of countless lives, making every technological leap a step towards safety.